All right, everyone. Thanks for joining the Data Science for Managers session. My name is Brandon Krakowski. I'm the head of experiential learning and education at Analytics at Wharton. We're super excited to be partnering with WAAC to host a whole series of interesting workshops and talks throughout the year. In this session, you're going to learn about a day in the life of a data scientist from a manager's perspective. Your instructor, Ross Hochwert, he's a data scientist at Meta. He's also an alum of the MBA program, graduate of Penn's data science program. He's also a nice guy. I think you're going to like him. So without further ado, Ross.
Cool. Thanks, everyone. I frankly expected like 3 people to show up, so the fact that there's so many, I'm excited. Okay. Who am I? My name's Ross. I'm a data scientist at Meta. Before that, I was an associate at Patterson, which is a PE firm. I was in operations there. And I started my career at Bain & Company as a consultant for 2 years. Education-wise, like was mentioned by Brandon, I got my MBA here at Penn, graduated last year, and also my data science dual degree. And before that, I was at WashU. Any WashU people? Definitely not. So, yeah. Where I did my BSBA and this master's degree program. This is my fiance over here. She also graduated from Wharton. We just got engaged a few months ago. This is my family at a wedding. Okay, why should you be here? One of 3 reasons. Number 1, you want to become a data scientist. Number 2, you want to learn about how to work with data scientists and what data science means. Number 3, you like hearing my voice. Hopefully it's one of the first 2. If it is one of the first 2, please reach out, especially if it's the first one. Meta is trying to hire again, other firms are trying to hire. I think the more MBAs that become data scientists, the better the world will be. I think it's a really great marriage of 2 skill sets. So my email is somewhere. Please email me, please reach out if this is interesting to you. What should we talk about? Here are a few things I think we should talk about. What is data science? What do those building blocks look like? How do I spend my day when I'm not talking to MBA students? And then a little bit on some descriptive and predictive analytics, just enough to be dangerous on that skill set. If there's anything that you guys are interested in that's not on this list, shout it out. An hour later, or tell someone, pass a note. Okay, so building blocks of data science. In my opinion, there are really 4 meaty activities that one should consider when they're thinking about data science. The first is descriptive analytics. What happens historically? You will answer questions like, how did my revenue change year over year? Did my decline in profits come from price or volume, like some root cause analysis? This is everything I do as a consultant. And I'm sure many of you who summered as consultants or are previously consultants or finance, a lot of you live in this first bucket of descriptive. The second one is predictive or supervised learning. And it's basically given the history, given X data, can I predict, classify, or forecast Y? Basically something else outside of my data set. Linear regression is an example of supervised learning. Neural nets is supervised learning. Anything predicting is supervised learning. So what will my revenue be next year? What items should I recommend to my customer? Questions like that. There's unsupervised learning, which is pretty much out of scope for today, but that's more or less, can I organize my data in a meaningful way? If I have a lot of X, can I coalesce that X around some sort of grouping where I'm not telling my computer exactly what the objective function is, what I'm trying to shrink, but rather just kind of make some insights from the data. The most relevant for you guys would be, can I group my customers into relevant segments? So I'm not telling the formula, hey, find all the buyers and the non-buyers, but I'm rather saying, hey, find 3 or 4 different cohorts that all kind of look like each other. And then the data will come back and I can kind of delineate that customer cohorts and try to find out what makes them tick. Or outlier detection is another example. And then finally, experimentation on causality. How does changing X impact Y? So you do a lot of this in product, PM work. Should my call to action say submit now or click here? Which color button gets the highest conversion rate? You're running experiments, you want to make sure that they are statistically significant. We're going to talk about the first 2 today, but all 4 I think are relevant depending on what type of people you're working with or path you choose. If you're a product analyst in a tech company, you sit a lot in the first and fourth buckets. many, if not most of the data scientists I work with at Meta, they do 80% of the work is on the last bucket, causality and experimentation. We're running millions of experiments at any time across our billions of users, trying to see which will get users to click more, engage more, and have a better experience. If you're a management consultant, like I mentioned, you're probably in that first bucket. You're really working on root cause analysis, descriptive analytics, what happens. If you're a quant hedge fund analyst or some sort of ML engineer, you're definitely in those middle two buckets. You're trying to make money. You're trying to, given X, which is called an array of data about stocks, which stock will pop first next year or something, right? You're trying to make money on betting. There's some excellent courses at Wharton on supervised learning for stocks, for finance, quantitative finance. I highly recommend you look into them if you're interested in that. And then finally, like a marketing analyst, which is kind of like a broad position I don't know a ton about, but I imagine you're kind of sitting in that first bucket and those last two, less than the supervised. Data scientists in big tech, you can be one of, you're looking at all these tools in your toolkit, depending on what your project you're working on. Okay, so day in the life of a data scientist. This is my actual real calendar. I blacked it out for some privacy reasons, but you should kind of get a sense for what I do during the week. This is literally from 2 weeks ago. So first thing you'll probably notice is I have a lot of white space. I don't do a lot. Or I don't have a lot of meetings, I should say. I do things. Right, like Monday, like no meetings, right? No meeting Monday. The next thing you should notice is that my day usually starts pretty late in the afternoon. So Monday, Wednesday, Thursday, I don't really have things till 1 o'clock in the afternoon. I think at Meta, they really prioritize IC work or individual contributor work, where you're actually heads down working on problem solving things. Just to kind of go through the color coding here, the orange is presentation. So this is either I'm receiving a presentation, like a lunch and learn on Fridays, or I'm giving an update. So this Tuesday one at 9 a.m. was actually quite important. It was to a very high up executive on some work I was doing. It went super, super well. But really, I spend most of my time in these blue and green meetings, blue, green, and purple, which are either one-on-one with teammates, a team meeting where we're kind of discussing work we're doing, or my favorite in purple is the brainstorming and problem solving, where you're kind of getting together with a group of people, working through some thorny problem, what approach should we do, what evidence do we have, what's the root cause, blah, 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 blah. It's super collaborative, but at the same time, my calendar as a consultant would look a lot different. It would probably be the reverse. All the white would be meetings, and all the meetings would be free time. I think the kind of person who conceives in data science is someone who is somewhat research-oriented, right, and independent. But at the same time, like I mentioned, I think that MBA skill set, focusing on what matters, focusing on impact and those influence, I think is super important as well. I also go to the gym on Fridays at 10:30. Okay, so let's talk a little bit about descriptive analytics, and we'll go through a case study after talking about some common tools and common workflows. I think everyone kind of knows descriptive analytics, but they may not know all the tools that exist, right? Like when I was a consultant, right, I was all in Excel, that first row. There's tons and tons of, apps and coding languages out there that can help you. I discretize this table by, 4 different functions. Can it extract data, manipulate data, visualize data, and can it consume big data? Big data, let's just say it's over 1 million rows. So Excel can do really well on the first 3, but not so good on big data sets. Power BI, Tableau, Looker, these apps, honestly, when I look at this chart, I think they're all the same, right? Like, I don't really see a difference. I think whatever your preferred workflow is, whatever your company says is right, is what you should be using. For me, I live in Excel and SQL. And for the record, I'm the only idiot MBA in my team who uses Excel. Everyone else uses Python and SQL, and they all laugh at me. But, whatever. I think it works fine for me. So, there's lots of different tools out there. They all pretty much do the same thing nowadays because they're all pretty advanced. Do what makes you happy. I will say SQL is probably the most universal of all of them. Common workflows, I think you can extract the data from SQL that allows you, SQL is a coding language, allows you to tap into a big data set. You can manipulate that data in R or Python and then kind of chart it up, make it look pretty, and Tableau, Power BI, Looker, Excel. You can go straight from SQL and then chart it up. Or you can create this pipeline, every day it loads from SQL and powers it directly onto one of these apps. Again, they're all the same. I think the only difference is, are you doing one-time ad hoc analyses like on the left-hand side, or are you trying to do some continuous reporting? Those are probably the difference in what's the most preferred workflow. I think the big takeaway here is that data engineers are super important, and you should learn their skill set or become friends with them, because they can really make or break your life. So let's go through a quick case study modeled after consulting case studies. And this is actually a real case study. So this is based on my time in private equity, real client that I worked with, a real portfolio company I worked with. Veterinary hospital, pets, not war vets, 500 locations. And you want to report that segments all customers based on their patient status. And it would be a pet, but just imagine it's a human. The real example is dentistry, but I changed it to anonymize it a little bit. But it's an active patient is someone who's visited last year. Lapsed patient is every 12 to 24 months. And churned is more than 24 months. And the idea here is that everyone should come in for an annual checkup. All dogs, cats, and in-betweens, you should at least be seeing once a year. The data engineer comes to me and says it's going to take 10 hours to run this report. Why is it going to take so freaking long? So databases are slow for the same reason that cars are slow. This is kind of ham-fisted analogy, but basically you can have a bad engine, a bad designer, a bad driver. Right? The engine is they're using SQL or no SQL or other ideas out there. Bad design, we'll talk about right now, right? How's the layout of the database? What are the columns? What are the rows represent? Or bad driver, which would be your data engineer, your data scientist, who's maybe writing a bad query. That's out of scope for today. As a non-technical person, right, as a manager, it may be hard to determine which of these three is the issue. But I would implore you to think about the database design. So let's pretend that the database is structured as transaction data. So each row here represents a transaction where a credit card is ran right on some sort of system. And it comes with what date was the credit card ran, what's the transaction ID, what customers it's associated with, which hospital, right, what location, what was the service rendered, and what was the price or kind of the revenue of that transaction. This is an incredibly common data set structure, by the way, transaction data or usage data. Almost every data set at Meta is structured as some sort of transaction or usage. So assuming you have 2,000 patients per hospital, 500 hospitals, 10 transactions per year per patient, 5 years of data, it's 25 million rows of data. Big, right? Not insanely big, but big. So every time we want to run the SQL query, right, you can imagine there's 3 steps. The first step is to find the last visit per customer. So in this example, we go row by row. We kind of keep track of what's the latest transaction for that customer. So in the first row, ABC customer had a transaction on December 31st, but then the next day they must have come back and they had another transaction. Right, and they look further down and actually had another transaction on January 3rd, so that becomes the latest, which I highlighted red. DEF customer only came once, right, in this data set, so their latest transaction is January 1st. So then I kind of deduplicated my data set below, and now I have one customer in my data set, which is about 1 million customers, and it says when was their last transaction. I then can assign each customer to their bucket, so I go through and I look at each customer and I say, okay, was it more than 12 months? Was it more than 24 months, 12 to 24, or less than 12, so I kind of assign them the bucket. And then I group and sum the data, which is kind of like a pivot or a sum if in Excel, which I'm sure everyone knows about. So how many rows of data do we read at each step? So step 1 is to eliminate all the duplicate rows, keeping only the last visit per customer. So we have to go through every single piece of transaction data, 25 million rows. The next step is to assign each customer to their bucket. So we go through 1 million rows, because there's one per customer. And then finally, we can do step 3, which is group and sum the data. Again, we go through one last time, 1 million rows. Clearly, the bottleneck is the 25 million rows, which is to say that if we had a better database design, we wouldn't have to go through every single transaction every time we wanted to run this report. So what if we maintain a customer database? If we maintain a customer database, which only had 1 million rows, one per customer, and it was updated every time the customer visits, we could reduce it by a factor of 25. It may seem like a silly little example, but it is real that you should be thinking about what's the database design, how often are you pulling different data sets, different columns from the different data, because it can seriously, increase or decrease the amount of time needed to pull whatever reports you're looking at. So this is actually like a 3-month project. We ended up hiring Deloitte to help us kind of build this customer database. Because it was taking so dang long to load these reports all the time. I think the takeaways is that, as a non-technical person, it's not your job to write good queries or choose good engines, right? That's firmly in the data science or data engineers toolkit. But you should have an opinion on database design. Always think through things like, what are the fields I need in my data set? What analyses am I running and how often? How often will those analyses be refreshed? Right? And communicating that to the data engineer, thinking ahead, will really make your life a lot better. Last thing here is work backwards from the answer. I think this is really obvious, but I think it bears repeating. Some people call it being hypothesis-driven. Some of the marketing folks think it's backwards research marketing. They're all the same names. Basically, think about what's the answer you're looking for, what data set, what chart are you going to generate from the data, and then work backwards from there. People have a tendency to throw the kitchen sink into their data sets, and it ends up just creating this unruly, unusable data. Okay, predictive analytics. This is a little bit more exciting. Right, I think this is where there's a lot of attention these days. Even though I spend most of my time in descriptive, people really like predictive. So predictive, like we talked about, right, classification, prediction, or time series forecasting, these are not easy, but certainly cover a lot of the grounds. Which of my customers are married versus single? You have a binary, or you have some sort of categorical prediction. Prediction how tall my child will be, that could be continuous, so 5 feet, 6 feet, 7 feet. Time series forecasting, this could be how many widgets do I sell over the next few years, 22, 23, 24. All these are key activities of predictive analytics. Predictive analytics, right, there's data science, there's statistics, there's machine learning, there's AI. I found this, crazy infographic online. I don't care. I don't give a shit. I don't think anyone really cares what the differences are. I think they're all just different tools under different names that kind of accomplish the same goal. This is a neat little graphic that I found. Statistics plus machine learning equals statistical learning. I don't know. Like I said, I don't really care. I think they're all kind of the same. I think they all have this similar premise, right? You have historical data, you have some sort of model or machine learning, and out comes the predictive model. I think today, the most basic predictions, thinking about classification, right? You have logistic regression or multinomial. For prediction, you have a linear regression. For time series forecast, you have other types of regressions or the Delphi method. Does anyone know what the Delphi method is? Where you just ask the salespeople, what do you think sales will be next year? And then you just average answers. But then there's these new tools, right? Everyone's so excited about neural nets, decision trees, SVM, k-nearest neighbors, Remax, Profit. Profit is a meta tool. They all kind of accomplish the same thing. They're all just V2 of the V1s of the world. They're all implemented in Python and other libraries like TensorFlow, PyTorch, Scikit-learn. And I think we'll talk about neural nets today. I made this presentation last year. This was the slide. Why is everyone talking about neural nets? I think actually it's why is everyone talking about large language models? That's kind of the new hot thing a year later. They're really the same thing. Large language models, the ones that are used today, are a subset of neural nets, right? A rectangle is not a square is a rectangle. And we'll talk a little bit about them. But neural nets, just to start, the high-level theory is it's named after your brain, right, with neurons. Whoever's taken high school psychology or college psychology, you probably recognize the diagram on the top right. Right, you have these dendrites, these little, arms that kind of reach out and receive information. You have the cell body, the nucleus, which processes that information. And then an axon, which outputs that information to other terminals, right, to be picked up by other dendrites. Same thing on the bottom chart, that's what a neural net is. It takes inputs, right, the dendrites, it takes these new data. It has some sort of calculation in the middle, and this word bias, which we'll talk about in a little bit. But it basically does some sort of calculation, and then it spits out data to then be processed by more neurons. Think about a traditional regression, right? Y equals mx plus b, right? Slope of a line. Another way to write it is, b naught plus b beta 1 times x1, or a multiple linear regression, right? Your dependent variable is y. You can have as many coefficients as you want, right? Betas are the coefficients, or b's the coefficients. and x are your independent variables. Right? Simple stuff. Another way to write this is to think about it as inputs and outputs. So my input for my linear regression, right? I'm just taking my b's and moving them over here, changing, 90 degrees, rotating it. But I have my input times my beta 1, input times my beta 2, right? You add it all up and you get this output layer. The example I put here is how dateable you are. Very, very bad model, but let's just say it's based off 4 things. How tall are you? How much do you weigh? How good is your smile? And how nice are your eyes? There's coefficients, right? There's 1.2 for all of your height, minus 0.5 for your weight. It's a terrible example, probably not PC. I should probably change it. And then your smile, smile is great, people have eyes. So I like the better. Okay, so for a neural net, everything's the same, except I just add this little hidden layer in the middle. And so basically, right, I still have my height and weight variables on the left-hand side. I just have this hidden layer, which is in the middle, which allows me to combine these different variables in multiple configurations. So if I combine, height just goes to this blue node, which is just representative of height. But if I combine height and weight, maybe this node represents BMI, right? And then this node, height and weight in a different way, represents how strong you are, right? Because you can weigh a lot but be very strong, and then weight is weight. And so I've just taken these 2 input layers and turned them into 4 nodes, right, or 4 different, variables or betas. So I've taken my data, which only had, 2 signals, and made it into 4, right? And then I combine them back, and I get this datability metric. That's all it is, right? You're just taking your input layer and creating a fake or kind of hidden layer of more nodes, which is a combination of all the existing ones, and then using that to output another node. And you can imagine that you can keep stacking these, and the more you stack, right, the deeper the neural net gets. So again, the same example, I've just replaced the height, weight, and these hidden layers, which is x1, x2, right? The hidden layers, h1, h2, h3, h4. There is something I do know called a linear activation. It has to do with these hidden layers. I won't explain why, but basically you do some sort of, I would call it like a silliness to it. You basically either remove all the negatives or make them all positive or do something to these to kind of mess it up and add some randomness. We won't talk about why that's relevant, but it is relevant. And that's what makes a neural net really a neural net. So again, what's the point here? We have our input layers into outputs. This is our linear regression. The only difference with a neural net is you have this hidden layer where you take those inputs, you create more combinations to create a hidden layer, and then you have an output. And you can stack these and have more and more as you go along. This is what I was talking about before. If you don't add this kind of linear activation, you'll get a straight line. If you add it, you can kind of do some curved lines and start doing some cool, separation of your data. They're incredibly powerful, and they're becoming super easy to set up. They were all the rage last year, like I was talking about. Now we're talking about large language models and some other things, but these are things that you can set up in 30 minutes on a laptop and start training your own models to predict, classify, all those predictive analytics we were talking about before. So they're really accessible to the average person. Large language models. How do they fit in? Large language models are a subset of neural nets. Their predictive function, their objective function, is to predict the next word in a sentence. So there's this guy, J.R. Firth. He, is kind of the father of natural language processing, which is the kind of subset of, data science focused on things like ChatGPT. He had this quote: "You shall know a word by the company it keeps." That's kind of became the foundational exercise for all natural language processing. The best way to predict a word is to find other words that are used with it. So literally, back in the day, they would just create huge dictionaries of all the words that are ever said. How often does the word apple coexist with other words like oranges and whatnot? And you just find whatever word most follows apple, and that would be the prediction. Obviously, NLP, neural nets, large language models, have come a long way, but they're all based on the same idea. Just find whatever words are most often associated with that word. Exactly. So to predict the next word, find out what other words are commonly used with that. Why are you hearing so much about large language models? Really 2 big recent developments. Number 1 is more training data. So basically every word that's ever been written is now being used to train, right? Trillions and trillions of words that are pulled from the internet, which has its own issues. But that was really one of the bigger developments. And then the second one is this thing called transformers or self-attention, which is out of scope. The TLDR here is natural language processing up until 2017. More or less, you just predicted the next word based on the words that came before it. But it wasn't dynamic. You couldn't really read the previous sentence to predict the next sentence. Transformers or self-attention was this new development, which allowed these models to kind of look backwards and get context from whatever sentence was last said to predict the next sentence. A fun fact is that all of the papers written about transformers are named after Sesame Street characters, Bert, Elmo, and so on. So if you're at all interested, you should definitely check it out. Okay, quick note about bias amplification. I'd be remiss if I didn't talk about the downside of algorithms and predictive analytics. They can be biased and amplify bias, which are two different things. There's lots of examples, just Google them. Bias means that the world is biased, and therefore the algorithms reflect the world, which is bad, right? The world is a bad place sometimes. But sometimes they can also amplify bias, which means the world is biased, and the algorithms make it even more biased, which is kind of adding to the problem. So both are bad, but you should kind of know the difference and make sure you're calculating appropriately which one you're trying to solve for. So Amazon screening tool, famous example, they wanted to find applicants that look like successful engineers at Amazon. Guess what? Most successful engineers at Amazon are not females due to existing biases. Therefore, the algorithm found a lot of males. And so Amazon ended up taking down this tool, this screening tool, which was clearly biased against what a typical engineer looked like at Amazon. So bad. But the other bad is bias amplification. So let's do a quick case study here about why algorithms amplify bias. Imagine you're building a neural net which inputs an image of someone eating a salad and outputs if the person is male or female. These are real images, right? Like person eating salad. And you can see that in the training data set, it's like always a woman, right? You put person eating salad, it's always a one for some reason. So on this page, right, I see 2 men on the left, and then what is this, 3 men, and 6 females, it looks like. Let's imagine that your training set consists of 100 images, 70 women, 30 men, and you train an algorithm that works really well, 90% accuracy, which is really great. You then test it on new data, right? So this is our training data. You test it on the 70-30 split. You got 90% right. Now you're going to test it on new data, but your new data set is split 50-50 male-female, right? So this is a little bit more balanced, right? I found a data set that was more balanced. And your algorithm correctly classifies 90% of the images, but it has no idea on the remaining 10%. There's no signal. It has no idea. So it does really well on the first 90, but the last 10, it has no question. So with no other information, your algorithm's best guess would be to always say female, right? Because the training data was 70-30, so if you would know their signal, right, the probability is it's a female. So kind of the idea is like always guess C, right? Same idea, just go with what you know. Of the remaining 10, if half are female and half are male, right, that means they get half them right. So 5 out of 10 times. That leaves us with 55 female guesses, right? The 10 auto-guessed, and then the 45 from earlier, and then the 45 from earlier. So our accuracy is 95%, better than before, but now we're biased because our training data set was only 90% to begin with, but in this new test data set, right, we're now guessing there's 55 females, right, more than there actually are. So there's actually some really cool reading on this from a Penn professor who does a much better job explaining it. But kind of the basic idea is if your training data set is biased towards women, biased towards women, right, and there's no other signal, they're always going to default to whatever the data set is biased towards, which could continue to amplify the issue and create more bias in your data. How to stop it? It's super difficult. Some common solutions are to rebalance your training set, right? So you can spend more time making sure the data set is unbiased, which means make the world a better place, recruit people without biases, and so on and so forth. Or more likely, you're going to do it artificially by duplicating or resampling, female entries in this case, right? So make the data set more balanced by just copying and pasting the same rows of data over and over again. That way, your algorithm doesn't think that 70%, hitting the women button every time is more a better approach to get correct. There's also some new research, again from that Penn professor, on explicit restrictions on overguessing. right? So you can actually tell your algorithm, hey, I want this to be 50-50 woman and female, so when you're doing your guesses, you have to be within the constraints of those parameters. The problem, of course, is that your algorithm will likely, suffer some accuracy issues, but again, there is research on how to have the same level of accuracy, but still maintain, bias restrictions. I'm not going to do the demos, especially because these are kind of outdated. There's much cooler demos. Just go to ChatGPT. But these are some other things you can do. The one on Google with the image classification is super cool. You can actually just put in images of you doing like YMCA, and you can train it off a few images of yourself doing that, and then ask it to classify letters, YMCA letters, and it does it with pretty good accuracy, and it trains and guesses within 5 minutes. Maybe with ChatGPT, that's not as exciting anymore, but a year ago it was pretty cool. That's all I had today, actually. So I think I went a little over, but I'm happy to take any questions or let you guys go back to Pret.
I have a question. I don't know if you could hear me, Ross.
Oh, yeah. Hey, how's it going?
Doing well. So my question is, as an MBA, how do you position yourself to get into a position like this versus others you're competing with who have like PhDs or different graduate degrees that are more analytical than ours?
Great question. So Meta had a program specifically to hire MBAs. They wanted to increase the level of MBA data scientists in the program. So from a recruiting perspective, that was kind of my pipeline in. I do not know the status of that. I probably should have checked before this. I think from a performance perspective, though, you guys will run circles around the PhD, folks who join Meta as data scientists, because while they have great technical grasps of concepts like neural nets or math, you guys have really great concepts of influence and presentation, which they do not have. And I think a common trap that my PhD colleagues fall into is working 6 months on a very research-oriented project only to present it and have people say, that's nice, but it does not make me make any decisions differently, right? I know more, but I will do nothing different now that I know this. So I think it's great to have MBAs on staff. I think we're much more, impact, change, decision-oriented, but, it's always a balance. Did that answer your question?
That did, thank you.
Yeah, thank you.
As far as the technical skills, as things kind of change in data science, are there any specific areas that you think would be best to focus on, or like emerging areas just to better direct focuses while learning?
Honestly, I think it's like same shit, different day. I think we always, we do so much causality and so much descriptive analytics, nothing's new. I think that's what you should be focusing on. It's exciting to do neural nets and, the latest and greatest machine learning, but the reality is, unless you're a PhD machine learning engineer who's going to join Meta or one of these companies as a machine learning engineer, which is a different role than a data scientist, your role is not going to be that hard, or it's not going to require that much. So do it for your own benefit, because it's exciting and interesting, but at the end of the day, I'm doing plus, minus, multiplication, division. I'm not doing crazy algorithms or anything. But it is cool. Yeah.
Yeah, so what are the common things you see MBAs who are in non-technical roles get wrong when it comes to working with their technical colleagues? And on the flip side, are there certain perspectives or tactics that you've seen be more effective in making them a successful collaborator?
Oh, wow, that's such an excellent question. I should write that down and add that as a slide. Off the cuff, I think there's kind of a stereotype, right, that technical colleagues are abused by non-technical colleagues, which I try not to do, right, to my data engineer counterparts, right? I think they're fundamental to the role, but I don't know, this morning I kind of abused them. I wouldn't say abuse, that's dramatic, but you need to get this data in by the end of the day because priorities have shifted, right? A VP has come down and asked for this, so I'm sorry, but like you're at the end of the bullwhip, right, with the bullwhip effect. I would say backwards research marketing is probably like number one, right? Work backwards from the answer you want. Don't ask the data engineer or the technical person for the entire thing. Be very clear about what decision this is going to impact, right? The more context, the better. I think when I joined, I think like one thing I've struggled with in my career is giving context to people, right? Because there's almost an insecurity I have that A, I would give context to you and you'd know it and you'd think I was talking down to you, or B, I wouldn't think that you needed the context because, maybe it's not relevant or it kind of weighs down your day. Those were both bad thoughts that I had, right? The more context, the better. Be incredibly transparent with your colleagues because they'll know things that you don't, right? I just think communication in general is very key. I'll sit on the question a little more because it's such a good question. I'll try to add something to this that more fully answers it. So those would be the highlights I would think about.
Thank you.
Ross, were there any courses from Wharton or Penn Engineering related to analytics or data science that you found super helpful, as well as resources from the school that helped you engage in experiential learning that you liked?
Okay, I could not recommend enough Influence by Cade Massey. Who has taken that class or wants to take that class or has heard of that class? Just everyone's hand should be up right now. That is, I know it's a non-technical class, maybe that was a bit of a curveball from what you were expecting, but I use that class every week, if not every day that I work at Meta. The things you learn, while they seem on the surface to be very basic, are incredibly important. Meta, like every 60,000 person company, is incredibly political. It is a company that registers $120 billion a year for a dead simple product, right? People come on the app, they use it, we sell ads, right? It's like not that complex of a supply chain. So your contribution to 20% year-on-year growth is incredibly hard to justify, right? Like how am I supposed to say that I helped the company make $20 billion more when there's 60,000 other employees? Therefore, your influence, your narrative, your way that you posture your work is the way to get people, to get promoted and get good reviews and things like that. So first and foremost, that class has been indispensable. Huge shout out to him. Technically, I took great classes at Wharton Penn. I don't know if I'm gonna get yelled at for this, but I don't use any of them really in my day to day. There's an NLP course I would recommend you use in the engineering school, which I loved. Who's Professor Mark Yatskovsky was the professor. He's excellent. There's a great artificial intelligence course also in the engineering school. Like all these are great, but it's kind of like reading a really nice book that like helps you think about the world. Like is really entertaining, but like I don't use my history of like World War II in my day-to-day job. It's just nice to know, I guess.
Thanks.
Yeah. Green blazer.
Ross, you have a background in many jobs that people coming from Wharton are interested in getting. Why did you make the switch from consulting, PE ops to data science?
Great question. Okay, so top three. Number one is I had the foundational skill set of a consultant at this point, which if you don't have, I would highly recommend it. I think while it's kind of a pain in the ass, and my fiance still works at Bain where we met, but it's a great job. You learn so much. So I had that, right? I didn't feel like I needed to go back and learn more about selling and pitching and things like that. I think number two is I think I wanted a job that was intellectually stimulating, right? I thought I wanted to be like this entrepreneur and go into ops and run businesses. So that's why I joined private equity as this ops person. It is incredibly taxing. It is not fun, right? For some people it's fun. For me, it was not fun, right? Like you were working with boots on the ground people to get shit done, people who have incredibly different incentives than you do, people who are working 9 to 5, making far less than you do, and I think incentivizing them to a change. I really could use Cade Massey's class before that, but it's incredibly difficult to kind of move people through the ropes. So I was kind of tired of that. I wanted to do something more intellectually stimulating. Therefore, I think data science was that nice bridge between using that business toolkit, using that strategy, but also having an intellectually stimulating job that can be fulfilling, and I get to think about problems and kind of run my brain like a calculator. So I enjoyed that. I will also say as an added benefit, not something I kind of knew at the time, the work-life balance is insane and incredible. Right, I'm here right now with you guys. Right, like I'm wearing something. I went to the gym before this. Like the lifestyle is unmatched compared to other common MBA career paths, private equity, consulting, banking. So I do think you should work hard and like learn things. Right, we're all junior in our career, so there's a lot to learn. But there's something nice about not having to work weekends until 10 o'clock at night and things like that. So those are a few of the highlights, I think. I'm also figuring it out, right? I may quit, right? I've been here like a year and a half. I don't know, it's a fine job, but right, like I'm all about building skill sets, so I may leave in a few months anyway and try something new. But that's why I went right now.
Thank you.
Yeah.
At a company like Meta, where there's a high proportion of engineers to other like less technical roles like data scientists or product managers, how do you navigate having a voice with engineers?
Yeah, great question. One that I asked many times when I joined the company. So I'm in a role that actually doesn't interact with software engineers very often. I'm in a very like strategic role at the company, but I was previously, when I interned over the summer, in a product role. So I'll try to give you like two perspectives. From a product perspective, like, and this stays between us, all you lovely people and myself, like, I think the pecking order at Meta is, software engineer, data scientist, PM, right? So software engineer on the top, data science, PM at the middle, and then, everyone else below that. I think in other companies like Google, software engineers hold even more power. There's kind of a steeper drop-off. At Amazon, it's much more PM focused, right, because they're a little bit more business and efficient, whatever. So you can kind of read online what people say, but there is a pecking order. So I think the question is, like, how do you as a data scientist work with your PM, your software engineer to, like, prove your worth? At the end of the day, the data scientists more often than not hold the scorecard. So the data scientist will tell the software engineer if the product is working or not. If it's not working, right, the software engineer doesn't get a good review at the end of the year because their metrics aren't going up. So you kind of muscle in with that. That being said, there is a pecking order, right? You're still number two. In my specific role, I don't really have to worry about that because I don't work with software engineers, like I mentioned. I'm in a much more strategic kind of consulting capacity. So it hasn't really been top of mind for me. But yeah, it is a problem. Or I shouldn't say a problem, opportunity. But I think at Meta, it is much better than it is at other tech firms where data science is maybe even far removed in the pecking order. Not a very satisfying answer, but that's the truth.
Division.
You guys ask great questions. Is that it? Yeah, like I said at the beginning, I expected 3 people to show up. I'm shocked that there's so many people here, and I'm shocked you guys stayed. It really means a lot, so I hope you got something out of it. If you're at all interested in becoming a data scientist or want to learn more, I'm more than happy to connect for 2 reasons. 1, I'm very passionate about it. 2, if Meta hires you, I get money, or we both may get money. Like, you'll get salary, I'll get a bonus, so it can only help. So please reach out. The more connections, the better. But yeah, thanks so much for having me.
Yeah, Ross, thank you. Oh, let me see. Well, I'm here. Anyways, thank you so much for your time. It was super insightful and fun as well. And if you can share your contact with the Wharton AI Analytics group, we can send it out to everyone here. If you enjoyed this session, which I think all of you did, please consider joining the Wharton AI and Analytics Club. We have a lot of really good events like this one lined up. On Thursday, we have an A/B testing event. It's sold out, but if you're really interested, we might be able to activate a wait list or squeeze you in. So contact us and also follow our Campus Groups events page. And also follow Analytics at Wharton. We partner with them to deliver events to you. Thank you so much, Ross. Thank you.